Hello everyone, I am Nikita and this is my walkthrough submission video for the role of Associate Software Developer at Better. I built Streaks, that is a small and very smart habit tracking application, and in this I have used Python for the backend part and SQL for the databases and React for the front-end part. In this walkthrough, I'll explain the architecture, key decisions and the AI tools that I have used to build this. This project has three major parts: backend, frontend and the AI guidance. The backend follows four-layer structure: routes, schemas, services and then models. Requests come into routes, get validated by the schemas and then go to the service layer where all business logic lives. And the special part here is that routes never directly access the database. This route is very simple. It just parses the input, validates it and calls the services. And if a route does more than this, it is a problem. The service layer handles all the logic. For example, when logging a completion, it catches database errors and converts them into a custom error instead of raw exception that is not usually being understood by the humans that are using the applications and have no technical prior knowledge about that. Now next we have data model and correctness. The completion model has a unique constraint and their habit ID and with the date. This prevents duplicate entries at database level even if two requests happen at the same time. Streak logic never gets broken because it is always handled inside the habit model. It counts consecutive completed days going backwards, and yes, I'll admit this, that one tricky case was when today's habit isn't logged yet. The streak should still continue from yesterday, and I fixed that in a later iteration manually. Next we have validation and safety. So all the input validation is handled via schemas. This includes required fields, limits, enums, color format and blocking future dates. The input that is invalid never reaches the service layer. And if the validation fails, the API returns a clear 422 error with specific messages and that are relevant to the error. Now this is the testing. There are 35 tests, no mocks, and they run in under a second. Tests use an in-memory SQLite database, so no setup is needed. There are three types of tests: root tests, services tests and model tests. The streak tests are especially important because they define the exact behavior and they include all the edge cases. I also fixed a bug here when these test files were affecting each other, and now each test runs with a clean database. Now let's talk about the front-end architecture. The front-end has a clear architecture and only one file makes API calls and standardizes all errors. A custom hook handles all the data fetching and components that are only receiving data and callbacks. They never call APIs directly to prevent This keeps things simple, testable and avoids unexpected behavior. The UI is intentionally minimal, and dashboard, habit cards, filters and a create edit model. And in this file where you can clearly see the AI usage, I have used Claude to do the basic structure of the backend and anti-gravity for the front end, and the errors that were being visible even after the AI users. I have verified them manually, and these tests are all written by me. The few things that I have fixed manually were the streak logic, the outdated SQL alchemy syntax, and the test isolation. I also added AI guidance where the files are needed to be restricted by bad patterns and ensure tests that must pass before any AI generated changes are accepted. Next, we have trade-offs and weakness. There are a few limitations here when streaks are calculated at runtime, which could be slow for large data. A better approach would be storing and updating the streak. But I choose the simplicity first, and yes, I can also optimize this and modify this version by reducing its time complexity and using a better data structure here. Also, there is no authentication and authorization. It's a single user app, so adding auth would require users, JWT, and updates across layers. That was not the part of the project, so I have not implemented that yet, but I will. Tests are using SQLite where production uses MySQL, and the validation still works the same, but enforcement happens at the different levels, and I have documented this too. Now this is the readme file that includes all extension ideas like punctuation, the bugs, and the test cases. What I'm most happy about is with how easy it is to extend the system, and new features require just minimal changes and don't break existing layers. That's the main goal of this architecture and the system design. Thanks for reviewing, and yeah.